So this is Geometry Day 1, and there is some geometry on the SAT, and because you only have 1 year of geometry in high school, this is stuff that a lot of people forget. So if you just do a little review of it, a lot of it will come back to you, and since the test is Saturday, this is a good time to do this. So the first part is just some definitions from geometry. An arc is part of a circumference on a circle. So if you just look at a section of the circle, that's an arc. The area is the space inside of a two-dimensional figure. If you bisect something, you cut it into 2 equal parts. A chord is another part of a circle. An arc's on the outside. A chord is a line that goes through a circle, not via circle. Goes through a circle, but doesn't go through the center. And it'll always be shorter than the diameter. A chord will be. The circumference is the distance around the circle. A diagonal goes from one corner of a square to its opposite corner. You can also have diagonals in rectangles and in other shapes. You can have diagonals. Diameter is a line that goes through the center of a circle, and it's the longest line that you can draw in a circle. That's how come chords, all the other chords, will always be shorter than the diameter. The diameter is always the longest. And equidistant means exactly in the middle. Equa meaning equal, and distant meaning distance. So equal distance, exactly in the middle. All right. Equilateral, a triangle that has 3 equal sides. And if it's equilateral, it is also equiangular. It can't have 3 equal sides unless it also has 3 equal angles. And those angles would all be 60. The hypotenuse is the longest leg of a right triangle, and it's always across from the right angle. Isosceles triangles have 2 equal sides, so equilateral have 3, isosceles have 2. And if they have 2 equal sides, they also have to have 2 equal angles. Parallel lines are lines that never intersect. Think of railroad tracks. If you look in the word, there are 2 parallel lines in the word. Perimeter, the distance around a figure. Circumference is the perimeter of a circle. We just don't call it perimeter. Perpendicular, 2 lines that intersect to form right angles or 90-degree angles. A quadrilateral is any figure that has 4 sides. A radius is another part of a circle. It goes from the center to the edge. It's half of the diameter. And volume is the space that's inside of a 3-dimensional figure. Okay. So now we're going to get into some of those things that were on the definitions. We're going to get into some of those more. So lines and angles. A line, a straight line, has 180 degrees. So any angles that you form by cutting the line will add up to 180. So because these two angles are formed when we cut this straight line, those 2 angles add up to 180. 2 intersecting lines, if you see an X shape like this, 2 lines that intersect, they form a pair of what we call vertical angles. Here and also here. We could also call these 2 C and D. A and B are equal, so are C and D. If they're across from each other in this X shape, they're called vertical angles, and they're equal. If you have parallel lines that are cut by a third line, this line's called a transversal because it transverses or it cuts across these 2 parallel lines. There are 2 kinds of angles that are formed, big ones and little ones. So if you look at these intersections here, 1, 2, 3, 4 angles, 1, 2, 3, 4 angles. Some of them are obtuse, they're greater than 90. Some of them are acute, they're less than 90. So we've got big, those are the obtuse ones, little, those are the acute ones. All the big angles are equal to each other, so here I've circled all the big angles. All the little angles are equal to each other, so all the ones that aren't circled are equal. And any big angle plus any little angle will equal 180. So if it's circled and you add one that's not circled, those add up to 180. But these have to be parallel lines for this to work. These 2 lines have to be parallel for this to work. Okay. All right. So definitions, quick quiz. Quick quiz number 1. So flip in your little packet.
Yes.
Towards the back. Actually, it's more towards the middle. It's about the 4th page back. You should see quick quiz number 1. There's an easy, a medium, and then a hard on the next page. So take about 5 minutes to do those, and then we'll go over them. Okay, so we'll go over these.
I'm not gonna lie, I could not get the easy one.
The easy one?
Yeah. I thought medium was easy.
Alright, so in the figure above, L1 is parallel to L2. Which of the following angles are not equal? Okay, so when you have parallel lines, let's see. And we have 2 different transversals, so we kind of have to look at each one. So on this first transversal, D, E, this one that's not named, and J are all equal. And then C, this one that's not named, G, and this one not named are equal. So C and G are on the same transversal. They're not circled. These are equal. And we're looking for what's not. Okay, on this other transversal, A, this one that's not named, this one that's not named, and M are all equal. And then all the ones that aren't boxed are also equal. So B and H are not boxed. They're equal. A and M are both boxed. Those are equal. A and K, one of them is boxed and one of them is not. Those are not equal. D and J are both circled, so those are equal. So the only ones that aren't equal are A and K. And if you look at them, they don't look equal. A is little, it's smaller than 90, and K is big. It's larger than 90. So you can tell by looking too, that A and K are not equal. And you can assume that something is drawn to scale unless it says it's not. So you can assume that those are drawn the right size. Okay, the next one. Here you have to figure out what A and B are so that you can plug them into this expression for A minus B. So we know that there are 1, 2, 3, 4, 5 A's, and those have to total up to what? 90, right? Because these 2 total up to 90, so these 5 have to total up to 90, which means that A is 18. Mm-hmm. And then these 2 B's also have to total up to 90, which means that B is 45. So you've got 4 18s minus a 45 would be 72 minus 45, or 27. Okay, and then the hard. Okay, so this says figure not drawn to scale, which means that you cannot assume that these 2 lines are parallel. You would have to have proof that they were. Okay, so what I see here is that this is 40, this is also 40, which means that U and S would both be 140, right? Because these have to total up to 180 since they make straight lines. But that's really all I can assume from this picture. I mean, you can assume that straight lines are straight lines, but you can't assume that lines are parallel. So I can't start talking about R and T because I don't know for sure that they relate to the other ones. Luckily, U equals 140 is an option. And I know that for sure. That has to be true. So this would have to be E. S and T would be equal if I knew these lines were parallel. And R would be 40 if I knew that these lines were parallel. I don't know anything about the lengths of the line, so this is out of the
Miss Eason, if you are in the building, could you please dial 8112? Miss Eason, please dial 8112. Thank you.
Okay. So let's see. Oh, yeah, that's right. All right, so on to triangles. And this will probably be, we'll see how much we can get at. Okay, triangles have 180 degrees. So this is showing you a triangle and the measurements of the angles, and if you add those up, they add up to 180. The area of a triangle is 1/2 of the base times the height. Now, in a right triangle, the base and the height are the sides. But if it's not a right triangle, the base and the height have to make right angles with each other. So if your triangle doesn't have a right angle in it, you've got to draw the height so that it does make a right angle with the base. The perimeter, you add up all the sides. Right triangles have a right or 90-degree angle in them. Isosceles triangles, this is one of the definitions from before. These have 2 equal sides and 2 equal angles. We call the sides here that are equal the legs, and then the third side is called the base. And this angle up here is called the vertex angle. These are called base angles. So the legs are equal, the base angles are equal. Then you've got a base and a vertex. Equilateral triangles, these have 3 equal sides. That's what the word equilateral means. They're also equiangular. They have 3 equal angles. All the angles in an equilateral triangle are 60. Alright, similar triangles have equal angles. So in these 2 triangles, even though they're not the same size, their angles are the same. The angles are all equal. And then the sides are proportional. You can see here that all of these sides are half as big as these sides. If you took half of all the sides of the big one, you'd get the little one. Okay, right triangles. There's lots of stuff about right triangles. If you know the lengths of 2 sides, you can always find the third side using the Pythagorean theorem. However, on the SAT, you almost never need this theorem because almost every right triangle that you'll find is going to be a Pythagorean triple. So it'll either be like a 3, 4, 5, or a 6, 8, 10, or a 5, 12, 13. So this is showing you a 3, 4, 5. This is showing you if it wasn't a 3, 4, 5, you could have square roots or whatever as your sides. In 2 special cases, you only have to know one side to figure out the other 2 because the sides are in a constant ratio. And this is the 45, 45, 90 and 30, 60, 90 rules. You want to memorize these because it'll be easier for you to recognize them. A 45, 45, 90 triangle will also show up on square problems. It's half of a square. And 30, 60, 90 triangles will show up on equilateral triangle problems. The way to remember this is in a 45, 45, 90 triangle, the sides are x, x, and x square root of 2. So you've got 2 equal sides that are across from your 2 equal angles, and then your hypotenuse, which is across from your right angle, is one of those sides times the square root of 2. And then your 30, 60, 90 rule, we're just listing from smallest to biggest. Smallest angle to biggest angle, smallest side to biggest side. So 30, 60, 90, the smallest side is x, the next smallest side, is x squared root of 3, and then the longest side is 2x. So that's what this is showing you with these drawings. So if you're given one of the sides, you can find the other 2. And we'll look at that. I think there's some of these in the quick quiz. Okay, so we're on quick quiz number 2. So take about 5 minutes for this. Oh, and down here, in the last one, the shaded area is here in the middle. It's that little parallelogram there in the middle on the last one.